I'm Anil Kumar sharing with you a very interesting question on direct and partial variation. The question here is, classify each example as a direct or partial variation. Explain how you know. The first one here is, Anil is walking at a constant speed in front of a motion sensor. His distance after 1 second and 2 seconds from the sensor is 2 meters and 3 meters respectively. That's the first situation. You need to tell whether it represents direct variation or partial variation. The second one here is, Peter is walking at the constant speed in front of a motion sensor. His distance after 1 second and 2 seconds from the sensor is 1.5 meters and 3 meters respectively. Right? So these are the two situations. You have to justify your answer. Here is my suggestion. Now, whenever we talk about direct variation, we say that the variable y, which is the dependent variable, is proportional to independent variable x, or variable y is equals to constant over x. That really means that the ratio of y and x is always constant for direct variation. So this is for direct variation, right? Let me write down. Let us check whether we have direct variation or not. So in the first case, we are saying that his distance after 1 second and 2 seconds from the sensor is 2 meters and 3 meters, right? So we are saying 1 second, that is time, and the distance is 2 meters, and after 2 seconds, the distance is 3 meters, right? He is going with a constant speed. So let's check that ratio, right? So what do we get? 2 divided by 1 is constant. Time is independent, represented by x. Dependent variable is distance, right? So this results into k of equals to 2 divided by 1, which is 2. And here, what do we get the value of k? K is equals to 3 divided by 2. 3 divided by 2, which is 1.5. Now these two values do not match, and therefore this is not direct, right? Therefore, this is not direct variation. I'm not saying this is partial yet, okay? But now let's check the second one. We'll come back to this. In the second situation, Peter is walking at a constant speed in front of the motion sensor. His distance after 1 second and 2 seconds is, so after 1 second, the distance is 1.5 meters. And after 2 seconds, the distance is 3 meters. Now let's calculate the value of k. So k here is distance divided by time, 1.5 divided by 1, which is 1.5. In the second case, k is equals to 3 divided by 2, which is also 1.5, right? So k is constant. So we say we have a constant ratio of dependent to independent variable, and that proves that part B represents direct variation, right? So here, since k is constant, it represents direct variation. Now in the case 1, what you also observe that Anil is walking at a constant speed. So that means it is a linear motion, right? Walking at a constant speed. Since k was not constant, we can say that he started from not 0, somewhere else, correct? So if you go through this, in 1 second Anil travels 1 meter, right? So if I go back, what was the position at 0 seconds, starting position? See, I'll show you from the second one. Every second, Peter is traveling 1.5. So if you go back to 0 seconds, what do you get? You get 0 meters, right? So you see, you are adding 1.5 each time. Here you are adding 1. So if you get back to 0 seconds, how much will be the distance? 1 meter. Do you see that? So in this case, you could represent distance as 1 second is the original, speed is, because every second Anil covers 1 meters, as k is 1, right? So we'll say time plus 1. Do you see that? Where at 0 the position is 1. You get my point. Therefore, in the first case, it is partial variation. So this one is partial variation. So I hope now it is absolutely clear. So if you graph this situation and this situation, what you're going to get is, here the slope is 1.5, correct? Here the slope is 1, but starts with 1. This starts at 1, this starts at 0. So therefore, this is partial variation, right? And this is partial variation, and part B is direct variation. So simply by finding the ratio, we can figure it out whether it is a direct variation or partial. I hope that helps. Thank you and all the best.